Good evening. Today in this video we will be completing the last two properties of adjoint. In the previous video we completed the first four properties of adjoint. So the fifth property says us norm of t square, norm of t star is equal to norm of t. To prove this, we will be taking norm of t star y whole square is equal to, norm can be written as in the form of inner product that will be like this. Now we can write this as this, and then by applying squares inequality, this can be written as this will be lesser or equal to norm of t star y into norm y. Again, this can be written as norm of t into norm of t star y, norm into norm y. Now we see that in the left hand side we have square, and in right hand term we have one more term of t square, t star y. So by cancellation we will get that norm of t star y is lesser or equal to norm t, norm y. Now we know by definition of norm t star will be equal to supremum of norm t star y, such that norm of y is lesser or equal to 1. So this is the basic definition of norm. There are three equivalent definition of norm, and I have just written the definition of norm here. And then what we know that if norm y is lesser or equal to 1, then from 1, let this equation be 1. So from 1 we can write that norm t star y will be lesser or equal to norm t. It's just like that if 2 is lesser or equal to 5 into 0.2, even though you remove 0.2, this inequality will always hold. So the basic concept I applied here, the same concept is applied here, and that's why we got norm of t star y is lesser or equal to norm t. Now we got this, we got this inequality. Now if this inequality holds, then supremum of this, if anything is less than any quantity, then the supremum of this one will be also lesser or equal to this one. So supremum of norm t star y such that norm of y is lesser or equal to 1 is also less than norm t. Why we wrote this condition? Because in starting only we wrote that if norm of y is lesser or equal to 1, from 1 we can write that norm of t star y is lesser or equal to norm t. Now we have taken the supremum and we have put this condition and we got this one. Okay, now by here what we know that this is this is equal to norm T star. Because I wrote in the definition that this is equal to norm T star is equal to supremum of this. So supremum of this is lesser or equal to norm of T. So this left hand side is equal to T star we got. Now norm of T star is lesser or equal to norm T. Now replacing T by T star, we get norm of T star star is lesser or equal to, let it be this equation be 2, and this will be equal to lesser or equal to norm T star. This will be equation 3. Now in my previous video we proved the first 4 properties of adjoint, in that we know that T star of star is equal to T, and here we get norm T is lesser or equal to T star. That is equation 4, and from equation 2 and 4 we get norm of T is equal to norm of T star. This was the fifth one, and now we will see the sixth property that says, sixth property says us norm of T star T is equal to norm T square, which is equal to T star norm. We'll first prove this equality. Now to prove this, let T whole of x norm square, this can be written as inner product of Tx comma Tx, and by applying the definition of adjoint we can get T star of Tx the way we did in the to prove the fifth property of adjoint. The same process is adopted here, and we will get x here. And now this, by applying the Squar's inequality, we will get norm of T star Tx norm of x, and again this will be lesser or equal to norm T star, which is equal to norm, this will be equal to, we can write like this, this will be equal to norm of T star T into x. Okay, so this is there, and now by definition of norm T we know that this is equal to supremum of norm Tx such that norm of x is lesser or equal to 1. Okay, so we can also write supremum of norm of Tfx square will be less than, x less than 1 will be whole of square. Norm T is equal to supremum of norm Tx such that norm of x is lesser or equal to 1. So squaring both sides we will get norm of T whole square is equal to this whole of square. Okay, what we did, we have squared the equation, then we get this term. Now this will be equal to supremum of norm of T x whole square such that x is lesser or equal to 1. Why we didn't put here square? It's obvious that norm of x is less than 1, then norm of x square will be also less than 1. So the condition only holds for norm of x is lesser to 1. So the condition still get valid. So we wrote like this only. So norm of t square can be written as the supremum of norm of tx whole square such that norm of x is less than 1. And now if norm of x is less than 1, again that we did that if it's less than 1, then we can easily write this one as norm of tx whole square is lesser or equal to norm of t star t. Okay, now this is less than this, so definitely its supremum will be less than this. So supremum of norm tx whole square, we have already given the condition. If norm of x is lesser or equal to 1, we will write the condition here, norm of x less than or equal to 1, then this will be again equal to norm of t star t. Now this condition, now we know that this is equal to this, so this will get replaced by norm of t whole square, which will be lesser or equal to norm of t star t, which is equation 2. Which is equation 2. And now we already know that this is equation 2. And now we know that if we take norm t star t is lesser or equal to norm t star t by Squar's inequality, then we already know that norm of t square is equal to norm of t in the previous property of adjoint. This will be equal to this, and this will be lesser or equal to t square. This will be the equation 3, and we will get t star t is equal to norm of t square. We proved this side, and now you can easily prove this one also by replacing t star t by t star, and this equality you will obtain. So here we complete the properties of adjoint, and I hope that you would have understood this topic. And if you have any doubt regarding this, you can write in the comment section below. And if you are new user to our channel, please do subscribe, share, like our video. And if I have done any type of mistake, without any hesitation you can improve me, or you can write in the comment section that I have done mistake there. And thank you for your love and support. Thank you.